At the JK Mall grand opening, some lucky shoppers are able to participate in a money giveaway. A large box has been filled with many $5, $10, $20, and $50 bills. The lucky shopper reaches into the box and is allowed to pull out one handful of bills. Rad pulls out at least 2 bills of each type, and his total sum of money is $175. What is the total number of bills that Rad pulled out? So we have 5, 10, 20, and 50, right? So we have some combination of those, and for part A, we have to somehow total 175. Now, we're told this, at least 2 bills of each type. So he's got at least 2 that are $5, at least 2 that are $10, at least 2 that are 20, and at least 2 that are 50. So that actually tells me that he has 2 times 5 plus 2 times 10 plus 2 times 20 plus 2 times 50, right? So this is equivalent to, let's see here, we got 10 plus 20 plus 40 plus 100. So that's $170. Now we want $175. So obviously, you're going to add one more bill, which is a $5 bill. So you're going to add 5. So this actually becomes a 3. So we have 3 bills. So what is the total number of bills? We have 3 of these guys, 2, 2, and 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 bills is the only way in this scenario to come up with $175. Sandy pulls out exactly 5 bills and notices that she has at least 1 bill of each type. What are the possible sums of money that Sandy could have? All right, so this is similar, but the only difference is now we have 5 bills. So let's see what kind of combinations we can come up with. So we have a $5 bill, we have a 10, 20, and a 50. And we know that we have to have at least 1 of each. She has at least 1 bill of each. So then the scenario is that we have 1 more bill. Now the 1 more bill could be a 5, 10, 20, or 50. So let's see. Just having this, our base value is going to be $5 plus 10 plus 20 plus 50, which is $85. So that's the 4 bills. Now if we add another 5, it will become 85 plus 5, which is 90. So that is one sum. And there, we want you to find all the possible sums. Okay. If we add to that base value a $10 bill, then we get 95. If we add 85 to a $20 bill, we get 105. And finally, if we take that base of 85 and add a $50 bill, we will get 135. So 135, 105, 90, and 95, those 4 are the possible sums that Sandy could have. Now we have Lino pulls out 6 or fewer bills, and his total sum of money is $160. There are exactly 4 possibilities for the number of each type of bill that Lino could have. Determine these 4 possibilities. All right, so $160 this time. So he has 6 or fewer, so he could have 6 bills, 5 bills, 4 bills, and so on. Now, 3 bills and so on, right? So let's see if 3 bills is possible. The largest bill is 50. So even if all 3 were 50, I think he'd come up short because this is going to be $150. So he has to have at least 160. So the 3 bill is not possible. So I think the only possibilities are going to be 4, 5, and 6 bills. Okay, so for 4 bills, 50, 50, 50, and a 10, that will do it. And I don't think there's any other combinations with 4 bills that would total 160. 5 bills, all right. 50, 50, 50, and 5 and 5, that would do it. And also 50, 50, and then 3 20s, 20, 20, 20. That would also total 160. So that's 2 combinations. And then for 6 bills, I think there's only one way of doing it: 50, 50, 20, 20, and 10, 10. This would total 160. So these are the 4 possibilities. This one is 1, this one is 2, this is the 3rd, and this was the 4th. A parabola has an equation y is equal to x minus 3 squared plus 1. What are the coordinates of the vertex of the parabola? All right. So we have a situation where we are given y is equal to x minus h squared plus k. Now that's the standard format of these kinds of equations of a parabola, where hk is the vertex. So in this case, we can just look at the equation and see that my h is actually 3 and my k is 1. So the vertex is 3, 1. And I think that's it. So if you make a quick sketch, 3, 1, 1, 2, 3, 1. This is the x-axis. This is the y-axis. So this is the vertex. And because this is a 1 and 1 is a positive number, it's going to point upwards. So it's going to look something like this. Yeah. Well, that's not a very nice parabola, but you get the point. Something like that. It should be a little bit more symmetric, but that's okay. All right, part B. A new parabola is created by translating the original parabola 3 units to the left and 3 units up. What is the equation of the translated parabola? Okay, so our original vertex was 3, 1. So the vertex is basically what is being translated. So the new hk, that will be, let's see here, we've got to go up, we got to go 3 units to the left. So we have to subtract 3 units from the x-coordinate. So 3 minus 3 would be 0. And then we are going 3 units up. So we have to add 3 units to the y-coordinate. So that means 1 plus 3, and that's 4. So that means our equation will be y is equal to x minus h, which in this case is 0, squared, plus k, which in this case is 4, right? Just like we had up here, like that format. And when you have that, that will basically just be y is equal to x squared plus 4. Yeah, and that's it, really. All right, part C. We have to determine the coordinates of the point of intersection of these two parabolas. All right, no problem. So our first parabola was y is equal to x minus 3 squared plus 1. And our second parabola was x squared plus 4. So if you want to find the point of intersection, you have to solve this equation, set them equal to each other. So x minus 3 squared plus 1 is equal to x squared plus 4, like that. So that's going to be x squared minus 6x plus 9 plus 1 is equal to x squared plus 4. And the x squared cancel, and I think I'm just left with 6 is equal to 6x, and therefore x is 1. And substitute x equals 1 into either one of these, and you'll get the y-coordinate, which I believe is 5. So that means the point of intersection is 1, 5 of these two parabolas. Part D, the parabola with the equation y is equal to ax squared plus 4 with a less than 0 touches the parabola with the equation y is equal to x minus 3 squared plus 1 at exactly 1 point. Determine the value of a. All right. So the key here is that we've got these two equations, and this one, x minus 3 squared plus 1, and they touch each other at exactly 1 point. So basically what that means is that the point of intersection, there's only one possible point of intersection. So when you solve this equation, the quadratic will have just one solution. And if you remember, y is equal to ax squared plus bx plus c is equal to 0. This equation, if we were to solve it, the minus b plus or minus square root of b squared minus 4ac all over 2a. You guys remember that, right? Well, the key in this question is something called the discriminant. The discriminant is this guy right here. I'll write it here. Discriminant. If the discriminant is positive, this will give two roots, right? The plus root and the minus root. If the discriminant is 0, it will only give one root, because then there's nothing to add or subtract. So it would just be that right here. And that's the key to this question, is that the discriminant has to be set to 0. So this has to be equal to 0. And I'll solve that, of course. So, solving these two, set them equal to each other. Ax squared plus 4 is equal to x minus 3 squared plus 1. All right, let's see here. Expand this out, I guess. Ax squared plus 4 is equal to x squared minus 6x plus 9 plus 1. And then put everything on one side. I think that will make our lives easier. X squared plus minus ax squared minus 6x. And then all the numbers, I think, end up giving us a 6. And then this is 1 minus a x squared minus 6x plus 6. Okay, now we can use our quadratic. So my quadratic gives me a discriminant. Our discriminant is always b squared minus 4ac, right? So in this case, that would give me minus 6 squared minus 4, 1 minus a, and c in this case is 6, right? And then this has to be equal to 0 in order for us to have only one root, as explained earlier. So this is 36 minus 24 plus 24a, I believe. So this gives me 24a is equal to minus 12. So a is equal to minus 12 over 24, and that is negative a half. And I think that is consistent with what they said, which was a is less than 0. Great. A sequence of m p's and n q's with m greater than n is called non-predictive if there is some point in the sequence where the number of q's counted from the left is greater than or equal to the number of p's counted from the left. For example, if m is 5 and n is 2, then the sequence pp, qq, ppp is non-predictive because in counting the first 4 letters from the left, the number q's is equal to the number of p's. Also, the sequence q, ppp, qpp is non-predictive because in counting the first letter from the left, the number of q's is greater than the number of p's. If m is 7, n is 2, determine the number of non-predictive sequences that begin with p. All right. So hopefully you understand this. I'll explain it a little bit, I guess, better, or that one right there. Exactly what they said. It matches this criteria of non-predictive because in counting from the left, you can find a number of q's that is equal to or greater than the number of p's. So, for example, if you get to that point, the first 4 letters, you get to have counted 2 q's, and that equals the number of p's that have been counted thus far, which is 2. Now, this guy right here, very quickly, as soon as you just count the first letter, you have counted 1 q, and that already is greater than the number of p's. See what I mean? So the definition is right here, and it might be a little bit difficult to understand, but it's actually not so bad. But let's work with A now. If m is 7 and n is q, they want you to determine the number of non-predictive sequences that begin with p. Okay? So we have 7 and 2, so we have 9 spots here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters, I guess, right, that we have to place. And 7 of them are p's. So we have 7 p's. And the q's are represented by the n, so we have 2 q's. Okay. All right, so I'm actually going to just go by what they told me right here, which is this little piece of information right here in the question stem that begin with P. So they've already told you what it begins with, so that's very helpful. Okay, it begins with P. Now, for it to be non-predictive, that means this one has to be a Q. I only have 2 Q's to place, so the next one must be Q. And if that is the case, then that will be non-predictive, because if you go and count the first 2, in this first 2, the number of Q's is 1, and that equals the number of P's. So it matches this definition up here. All right, so far so good. Now, here's the story. We have to figure out, what do you do here? Well, what do we have left there? We have already used up 1 P and 1 Q. So we have 6 P's remaining and 1 Q remaining. Correct? So then it just becomes a probability or choose notation that from those 1, 2, 3, 4, 5, 6, 7 spots, you choose 6 for the P's. And then from the remaining 1 spot, you choose 1 for the Q. And then that's it. That's how you do it. So 7 choose 6, I believe, is, so what is it? 7 factorial, 7 minus 6 factorial over 6 factorial, and that just becomes 7. So there's 7 of them of this form. All right, so I think that pretty much takes care of that one. We got 7 there. Now we have to figure out another scenario. The other scenario, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? The other scenario starts off with PP. And the only way this can be non-predictive is for this to be a Q and this to be a Q. So as you can see, when you count the first 4, the number of Q's, in this case, equal the number of P's. That matches the criteria. But then we still have to place letters there. Now, what do we have left? We used up our 2 Q's and 2 P's, so we have 5 P's left. And there's only one way to put all those 5 P's there. From 5, choose 5, and that's only one. There's only one way of making that. There were 7 ways of making those. So when you add those up, we have 8 in total that match the criteria for part A of this question. Part B. Suppose that n equals 2. Show that for every m greater than 2, the number of non-predictive sequences that begin with P is equal to the number of non-predictive sequences that begin with Q. All right. Okay, so let's see what we can do here. So this time n is equal to 2, and m is anything greater than 2. So it could be 3, it could be 4, ... and so on, right? So what I'm going to do is I'm going to, obviously not going to go through every single one, 3, 4, 5. That's going to take forever. So what we will do is we will just look at it from the perspective of m, and then we will compare. All right, so first we have to look at the ones that begin with P, and then we'll look at the ones that begin with Q. Okay, so actually the ones that begin with Q are a little bit easier. So if we have Q, and then we have a bunch of letters that need to be placed. So the number of Q's in this case are represented by the n. So we have 2 Q's, and we have m P's. Got it? Okay. So the Q, this is the one that begins with Q, right? This is the first comparison. So if the Q goes first, then immediately I have created non-predictive just by counting the first one. Because in the first one, the number of Q's is 1 and the number of P's is 0. So the number of Q's exceed the number of P's. So it's already non-predictive. But so I can put it pretty much anything here. I just have to count how many combinations of letters can be put there. Okay, so we have to put in those letters 2 Q's and m P's, whatever m is. So let's talk about this. How many letters do we have? We have m plus 2, right? That's the total. M plus 2 is the total number of letters from here to here. But then we have to, the total number of letters from the entire, all the letters is m plus 2. So this actually is not 2. This should be 1. Sorry about that. And then we have to subtract 1 for this guy. This has already been placed. So the total number from here to here is m plus 2 minus 1. And then from those, we have to choose m to place the P's, these guys. And then we'll have 1 space left over to place this 1 Q, and then that's where we place it. So this is basically the equation. And this becomes m plus 1, choose m. And if you do the math there, it's just m plus 1. I'll let you do the math to figure out what that calculates to. All right, so m plus 1 is the number of such sequences. Now let's calculate the ones that begin with the letter P. If they begin with the letter P again, we'll have a bunch of spaces here, ... It begins with P. Now, if the next letter is Q, then it will become non-predictive because when you count the first 2, you will have counted 1 Q, and 1p, and the number of q's equals the number of p's, and that meets the criteria for non-predictive, or whatever it's called. All right, so then we have to place these guys. Now in total, remember we had m plus 2, but then we've already placed these two guys, so the total is m plus 2 minus 2. And then from those, we have to place how many? Well, we started off with 2 q's, and we had m p's. But 1 p and 1 q has already been placed, so we have to place here 1 q and m minus 1 p's, correct? So from the total, I have to put m minus 1 p's, and then from the 1 left over, I put that q there. So that just becomes m choose m minus 1, and m choose m minus 1 is equal to m. And I'll let you do that math. Okay, but we're still not done though. We still have a scenario where it starts with the p dot 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 like that, and then we have a q, but then we put another q like that. That scenario. Actually, no, that's not the scenario. Well, this one has already been done, actually. This one is counted up here. So that is actually already counted up here. Yeah. So I think what it would be is actually starting off with PP like that. And then these would have to be Q and Q, because this means that for the first 4, you have 2 Qs and 2 Ps, and the number of Qs match the number of Ps. Okay, so that's how you do it. Just as before, the total was 2 Qs and m Ps, correct? But we've already used our 2 Qs, so now we have 0 Qs, and then we have m minus 2 Ps, correct? So that means these guys up here, we have m plus 2 minus 4. Yeah, because the total is m plus 2, but we've already added 4, and then from those, we have to place these m minus 2 Ps. Yeah, and that's it. So this is actually m minus 2 choose m minus 2, which is, of course, just 1. So the total of these guys that begin with p are this m plus this 1, which is m plus 1. And the total that began with the q was m plus 1. So we have shown that the number of sequences that begin with a q, m plus 1, is equal to the number of sequences that begin with the p, which is also m plus 1. Determine the number of non-predictive sequences with m equal to 10 and n equal to 3. So we have 10 p's this time and 3 q's. Got it? Okay, so I think we will start just case by case and see where this takes us. And I guess the first one is when we start off with a q. So we have to put 13 of these guys. We're going to start off with the q. Now, if we start off with the q, immediately it's non-predictive, because no matter what we do afterwards, we've already filled the criteria, because the number of, up until that point, the number of q's exceeds the number of p's. So then we just have to fill in what goes in here. So that's 12 spots, right? From 12 spots, I have to put those 10 p's. And then from the remaining 2 spots, I put the remaining 2 q's. So that's basically the math there. And yeah, I think that's it. Yeah. Yeah, I'm pretty sure that's it. So this actually calculates to 66. And I'll let you do that, right? You can do that on your own. Okay, so now we're exhausted the situation where we started with the q. Now we have to start with the situations that start with a p. Okay, if you start with a p, then same kind of story. It's going to be p here. But then we have to figure out what happens next. And we have 3 q's in total. So another scenario is if you have a q as the next letter. Now, if you have this kind of scenario where you have PQ, then what we have remaining is these guys, and there's 13 in total letters, so we've already placed 2, so we have 11 more. And those 11, we have to place 9 P's and 2 Q's, I believe, right? 9 P's and 2 Q's. So that means we're going to have a situation where 11 choose 9, and then 2 choose 2 for the Q's. And 11 choose 9 times 2 choose 2 is 55. Okay. Now we have another scenario. I think we have 4 scenarios in total. So the third scenario, we got 66 here, 55 there. The third scenario is when you start off with a P and a P. Now the only way to make this non-predictive is that the next 2 are Q's. So then we have to place these guys, and we've already placed 4, so there was 13 in total, so we have 9 more. So from those 9, I think there's only 1 Q and there's 8 P's, I believe. So it becomes a 9 choose 8 scenario, and then a 1 choose 1, and that's 9. But this question is a little difficult because there's another scenario for 3. This is part 1. This is a part 2 for 3 also. And that is this guy. Some people will miss this one. It's a PPQ. It starts off the same. And then there's a P, but then there's a QQ. This is also non-predictive with the remaining 13 minus 6, which is 7 spots, right? And all of these 7 will pretty much, you've exhausted the Q's, so you just put P's for all of those. So it'd be 7 choose 7, and that's 1. So don't forget that one. And then finally, the last one is when you start off with PPP. And the only way to make that non-predictive is to make the next 3 Q's. And that means these guys, that's going to be 7 spots remaining, and all of those are P's. So that'd be just a 7 choose 7 type situation for the P's. So that'd be 1. So the 66 plus 55 plus 9 plus 1 plus 1. So we have 66 plus 55 plus 9 plus 1 plus 1, and that is 132, the total for this question. 20 cubes, each with edge length 1, are placed together in 4 rows of 5. What is the surface area of this rectangular prism? So surface area would be 2 times 4 times 5 plus 2 times 4 times 1 plus 2 times 5 times 1. And when you do this math, you get 58. So 2 times the top plus the bottom, 2 times the sides here, that side and this side that you can't see, 2 times the front and the back. So this is the top and bottom. I believe 4 times 1 would be the front and the back, and then 5 times 1 is the sides. A number of cubes, each with length 1, are arranged to form a rectangular prism of height 1, surface area 180. Determine the number of cubes in the rectangular prism. Okay. So this is a little bit different. This time what we have is a surface area is given to us, and we have to figure this out. So this is length times width plus length times height plus width times height. That's pretty much how you figure out the surface area. And of course you have to multiply by 2. Now let's see, did they give us any clues here? Surface area they gave us is 180. And then they gave us that the edge length is 1. So that means the height is 1. Okay. Yeah. Actually, it gives us specifically that statement, the height is 1. Okay. So that means that the L and the W I'm stuck with, but at least I can put 1 for the H. So that would give me this equation right there. And then we got to figure this out. Okay. All right, I think I can work with this and then try to figure out the number of cubes. This mathematical formula here. So I got 180 plus, actually I can divide through by 2 and just put 90 is equal to LW. So that should be equals plus L plus W. Okay. So now I've got to use some fancy algebra here. And what I'll do is I'll add a 1 to both sides like that. And what that will allow me to do is it'll allow me to factor this in a way that will help. So this becomes 91, and then this becomes, if I factor out an L, W plus 1, and this is W plus 1. So then this allows me to factor it further, W plus 1, and L plus 1. So as you can see, that definitely helps us. All right, so now we have two numbers that when multiplied together equal 91. Now, what is 91? 91 is, I believe, 7 times 13, correct? So we have 7 times 13 is W plus 1 times L plus 1. So since length is usually bigger than the width, I deduce that this is the 7 and this is the 13. So that means that W is 6 and the L is 12. So the number of cubes, since the height is 1, the number of cubes, since the height is 1, is just W times L. In this case, that's 6 times 12, and that is 72. A number of cubes, each with lead 1 centimeter, are arranged to form a rectangular prism having length L and width W and the thickness of 1. A frame is formed by removing a rectangular prism with thickness 1 centimeter located K from each of the sides of the original rectangular prism. Each of L, W, and K are positive integers. If the frame has a surface area of 532, determine all possible values for L and W such that L is greater than or equal to W. All right, so we have some parameters here. We have L is greater than W, well, greater than or equal to, I guess. And then we have, from the diagram, 2K has got to be less than W. Because if 2K was equal to W, then that would not make any sense, right? Because then this hole in the middle would not be a hole, because 2K has got to be less than W. Because if it was equal to W, then you pretty much cut out everything. And then similarly, 2K has got to be less than L. And then the surface area is 532. Okay, so let's calculate the surface area. So let's do top and bottom first. Okay, so top and bottom should be fairly straightforward. It would be just 2 times the width times 1. And that's just 2W. Okay, that's the easy one. I think the sides are also easy. That's going to be just 2 times the length times 1. And that's just 2L. Okay, so now we have to kind of take into consideration these K's when we do the front and the back. All right, front and back. Okay, so the full, if you just look at the full front without cutting it out, it would basically be just 2 times W times L, correct? But then we have to subtract from it, of course, the cutout. And the cutout is 2 times W minus 2K times L minus 2K. Yeah, I'm pretty sure that's what it is. All right. And then we have to do the inside sides. These guys right here, let me just try to shade it in. These guys right here, there's going to be 2, right? 1 on each side. Okay, those guys, let's see here. I think top to bottom is going to be L minus 2K. So it's going to be 2 times L minus 2K. And then we just multiply by 1, which is the depth. And I think that's it, right? Okay, and then finally, the inside top and bottom, that's these guys right here. That's going to be 2 times W minus 2K. And then since the width is 1 times 1. And I think that's it. Okay, so that's actually not so bad, because now I just have to do algebra. So that shouldn't be a big deal. I have to add this all up. If I add this all up, it becomes 2W for this guy plus 2L. And then this one, when you simplify it all, I'll let you simplify it. It actually becomes 4WK plus 4LK minus 8K squared. This guy right here. And then we have this one, which is going to be plus 2L minus 4K, and then this guy, which is plus 2W minus 4K, and all of that is equal to 532 according to the question. So now we've got this algebra to work with, and hopefully, similar to last time, we can come up with some sort of a final factored form that will allow us to solve this. Okay, so all this algebra, I'll let you guys do. You can simplify this pretty quickly. And I'll just get it down to the simplified form, and then I'll show you the factoring. So when you simplify this, it becomes this guy right here. Minus 2k squared is equal to 133. And, I divided through by 4 and a bunch of, or 2 or whatever. Okay, so now at this point, this is when the factoring starts in. So I'm going to factor out a k from some guys here. So from this guy, that leaves me with a w. From, where else can I, is there a KL in here somewhere? Yeah, sorry about that. This was actually an L. This is supposed to be an L. That's why we can get an L. And then this is just going to be minus 2k when I factor out a k from here. And then I just get left with these guys, which is just a w plus an L minus a 2k. Okay, that's good because the w plus L minus 2k can be factored, and then we just get a k plus 1. There's 133. Now, what is 133? I think it's 7 times 19, I believe. So I'm going to say that this guy is the 7 and this guy is the 19. If that's the case, that means my k is 6. Okay, that's pretty good. If my k is 6, then that means that w plus L minus 2k is 19. And since k is 6, that becomes w plus L minus 12 is 19. And therefore, w plus L is 31, correct? Yeah. Okay, so that helps. That really helps. And let's just remind us of our parameters here. This is important. We got to make sure we stay within those parameters. And those parameters tell me that w is greater than 2k, and therefore w's got to be greater than 12 since k is 6. Okay, so then we have to solve this. We have L, we have w, and we have w plus L is 31, and they're all integers. So let's see what kind of scenarios we can get. With L being, I think L being greater than or equal to w is also a parameter. Okay, so if w plus L is 31, and L and w are integers, and L is greater than or equal to w, the first scenario is a 16 and a 15. Then I think we can have a 17 and a 14, and then an 18 and a 13, and then 19 and 12. That one we get into trouble because that does not fulfill that criteria anymore. So this is when we stop. So I think these are the only three scenarios that satisfy the conditions of the question. So you can write it. WL can be either 15, 16, 14, 17, or 13, 18. And that completes this question.